So today we'll be looking at matrices. So again, this is our student workshop on matrices. We'll be live in about 5 seconds via the YouTube platform. So my colleagues will place that link in the chat. All right. So if you got kicked off, you can always go to the YouTube channel or so, and it will continue the session that we have right now. All right. So
one more thing, Mr. Lehman, before you go. So sorry. Friends, can you just place the school that you currently attend in the chat so we can know the schools that we are interacting, please? Just go ahead quickly and place your school name in the chat. If your school is not from Kingston, please to place the parish that your school is from. If your school is not in Kingston, please to place that parish beside your school name. Thank you. I'm seeing Katie, Dunoon, Vauxhall, Queens, Belmont Academy, St. Pius. All right. Big up all those schools. Norman Manley. I don't know how to pronounce this, Abukir High. I'm so sorry, Kayla, if that's not how it's pronounced. Mannings from Westmoreland. Camperdown. Keep them coming. Okay, back to you, Mr. Limi.
All right, thanks. So as Mrs. Latoya Shariah-Bennett would have mentioned that you would need the following items: calculators, pencil or pens, and of course your notebook. And if you don't have any notebooks, you can always go for some blank papers. All right. So again, I have 5 other colleagues which will man the chat. So if you have any questions via the chat, they will direct and give me some responses. So today's session, again, it's on matrices, but just the little basics that we should know, or what that we might know or will be knowing in the few minutes that we have here. So define the concept of matrix, establish or explain, I should say, the basic concepts associated with matrices. And lastly, solve problems involving matrix operations, such as addition, subtraction, and the big one, multiplication. And we'll get to why, or to see if there is actually a division. All right? So these are the tasks or the objectives that we have ahead of us. Is everybody on the same page? Is everybody cool with this? All right. All right. So with that being said, we have a little brain teaser. All right, good. So we have a little brain teaser, a little true or false, in order to get your brains, ticking. So the first one. So the first question, we have -9 added to 7, and it's equal to 2. Now, is that true or is it false? What do you say? I'm seeing a lot of true. All right, true. All right. All right, we're saying true, and that's fine. But is it really true? Now, most persons would have started off by saying true. But remember that -9 added to 7, it does not give you 2. It gives you -2. So that is indeed actually false and not true. All right? So we started off with the truth. But again, we need to check over our work. All right? Next one. 2 is the reciprocal of a half. Is 2 the reciprocal of half? So the second question. 2, is it the reciprocal of a half? Is it true or is it false? All right, I'm seeing a majority of the true. All right, I won't waste any more time. One individual is saying false. All right, let's see. So it is indeed true. Now, why is it actually true? How can we write 2? You might see 2 and say, oh, it might not be like that. So I can actually have 2 over 1. Because 2 is the same thing as 2 over 1. So the reciprocal of that is actually a half. In other words, whatever was at the numerator becomes the denominator. And whatever was at the number that is at the denominator will now be at the numerator. So 2 or 2 over 1 is actually the reciprocal of a half. All right? Just emphasis on that for individuals who would have gotten that incorrect. All right, what about the third question? A multiplied by 0, is that equal to A? A multiplied by 0. Is that equal to A? True or false? A lot of false. Jamarian, all right. Janika, Sasha, all right, false. All right, we all agree with that. I don't see any true. All right, okay. So It is false because A multiplied by 0 actually gives you 0. So in other words, anything multiplied by 0 gives you 0. And remember, you can raise your hand if you have a question, and my colleagues will direct me to that individual. All right? What about this one? If 2x minus 4 is equal to 6, then is x really equal to 1? Try that one for size. All right, false. All right, so if you're saying it's false, you have to give me the answer for x. What would x actually be then? All right, so one person says 5, x equals 5. All right, cool. X is equal to 5. All right, and the statement is false. So let's see. It is indeed false, and we did that quickly, or mental math, and we got 5. Again, 2 multiplied by 5, just using the answers, just using substitution. So 2 multiplied by 5, sorry for the bad handwriting, minus 4. So 2 multiplied by 5 gives you 10. 10 minus 4 gives you 6. And this is when x is equal to 6. So the statement of x equal to 1 would be incorrect. All right. Is everybody okay with that? We have 4 more. Is everybody okay with that? You can say yes or give me a thumbs up, whichever it is. All right, cool, nice. But what about now? A negative added to a negative. Does that give you a positive? A negative added to a negative. Does that give you a positive? Is that statement true or is it false? I'm seeing a variation. So not just look at the word, but you want to actually use something numerical. All right? Just to test that theory if it's actually true. So let's say we have a negative number, -1 added to -1. What will this give us? -1 added to -1. What will that give us? -2. All right? So it's not +2, it's -2. And if we wanted to show that on a number line, we have 0, -1, -2. So we start at -1, and then we are going to add -1 to it. So we're going to the left and not the right. All right? So again, something for you to think about. So a negative added to a negative gives you it does not give you a positive. As Lindo would have mentioned in the chat, a negative times a negative gives you a positive. All right? So let's again take the necessary precautions. Check over your work. Use numerical values in order to understand what the statement is saying. So it is indeed false. So negative added to a negative is a negative. What about n multiplied by 1? Does that give us 1? Is that true or false? Is that statement true or is it false? N multiplied by 1, does that give us 1? Is that true? N multiplied by 1, I noticed somebody said it should give you 1n, but remember, that's not 1n, it's what? 1. So is that statement false or is it true? All right, I've seen a variation. So that answer would be false. N multiplied by 1 gives you n. And someone would have said 1n. It is the same thing. All right? So just for emphasis again, we can have or 1n. All right? N is the same thing as 1n. So let's move. What about 6 multiplied by -4? Does that give us -24? Is that statement true or is it false? All right, I'm seeing a lot of truths. Yes, it's -24. All right, nice. And the last one, this one is a bit tricky, but let's see if we can push through. 3 minus -8 added to 2 is equal to 13. Is that statement true or is it false? All right, I'm seeing a lot of true, so I can reveal. So that is indeed true. All right, thanks everyone for, sending those messages in the chat. So let's continue. So as I said before, that was a little brain teaser. Now we're on to the first objective, or the first task that we have at time. Define the concept of matrix. Have you ever seen that definition, or do you know what is a matrix? You have seen examples, have you seen examples, etc.? So you can type in the chat or you can raise your hand and my colleagues will allow you to speak via the mic. No? All right, no. All right. All right, a set of numbers arranged in rows and columns. Almost there, no. An array of characters enclosed by brackets. And we'll speak about those characters in a bit. All right, so let's get straight at it. So what is a matrix? Now, generally speaking, we have a matrix. Would you say that is that singular or is it plural? What do you think about that? Is a matrix a singular or a plural? All right, a matrix can be, okay. All right, singular. So, okay, matrices are singular. So what do you think, or what do you know of the plural of a matrix? What is that called? All right, plural is the matrices. So we have that on the top right. So the plural is matrices. So once you see more than one, you start saying matrices. And it's singular when it's only one matrix that we have. So I would have seen that persons would have mentioned the rows, the columns, elements, or even entries via the chat. Now, all right, and I'm getting a next definition by Kayla Brown, a set of numbers arranged in rows and columns so as to form a rectangular array. The numbers are called elements or entries. All right, and I think you're typing still. So based on our definition on the screen, a matrix is a rectangular arrangement of numbers into those rows and columns that we would have mentioned, and then it is usually enclosed with a curved bracket. All right? Is that okay so far? So we have the arrangement, the rectangular arrangement of the numbers of rows and columns, and it's by the close, a curved brackets. All right? Killian, what do you mean? You can type it in the chat and I will address it shortly. And how do we denote matrices or matrix? We have a capital letter. So once you see a capital letter, capital A, capital B, capital C, and it's equal to a rectangular array with a curved, enclosed curved brackets, and you have elements, as some persons would have mentioned. So every single time when you have an entry in that matrix, it is called an element. So those words were used earlier, all right, by, who was it? By Kayla Brown and others. So let's look at this matrix B. By the way, what is that matrix called? I just said a matrix, but what is the name of that matrix that we're going to look at now? Can anybody tell me in the chat? You can go ahead and type. All right, you said a row matrix, but what is the name of the matrix that I would have highlighted? Okay, B. So that's what I'm looking for, and it's a capital B. So again, capital B. All right, so just seeing if you are paying attention or listening keenly. All right, so we have the matrix B. And let's test our definition. Do we have the curved brackets? Do we have it enclosed with curved brackets? Yes, thumbs up. What do you think? Do we have the, all right, we have the enclosed curved brackets. What about, do we have any rows and columns? Do we have any rows and columns? All right, yes. All right, cool. All right, so we have the rows and columns and it's in a rectangular arrangement. Cool. And then we have the name of the matrix. Now, how many rows do you think we have? How many rows do you think we have? We have 2. All right, fair enough. So could you tell me the elements or the entries that are in the first row? Go ahead. Okay, 4, 6, 2. All right, cool. All right, so that is indeed correct. We got that right. So that's row 1. What about row 2? Could you give me the elements or entries for row 2? All right, fantastic. We have a lot of bright individuals over here. All right, so we have row 2. All right, what about the columns? How many columns do we have? How many columns are you seeing right now? All right, 3. And what is in the third column? What elements are in the third column? All right, 2, 1. Yeah, a shot, man. All right, what about the second column? It's not 60. It's have to be 6, 0. All right. We generally don't write the comma, but yeah. All right, so column 1 has 4, 5 as the elements or the entries. And as you would have rightfully said, column 2 has 6, 0, and column 3, 2, 0. All right, is everybody okay with that so far in what we're doing? All right, cool. Yeah, I'm getting some thumbs up. Cool. All right, let's continue. So we have a new subheading, which we call a matrix dimension. And another word that you might see is order. Is there another word that you could see if you have done this particular topic already? Have you seen another word that you could use besides matrix dimensions and order? Anything else? All right, Shani, sorry if I'm getting that wrong. So size, all right, cool, nice. So the size or the dimensions of the matrix is also known as the order of the matrix. All right. So the word dimensions is actually plural, right? So that means you have more than one, right? Dimensions, and you would have mentioned those dimensions. And we'll go into it a bit. So the order of a matrix, the size or the dimensions of the matrix is actually the what? The number of rows, and it is followed by the number of columns. So the number of rows is always given first, then we have the number of columns. So some individuals might have highlighted in the chat 3 by 2 or 3 multiplied by 2. I'll just say 3 multiplied by 2 right now. And that would have been somewhat inconsistent, right? Because the order the order of the matrix or the size or the dimension of the matrix has to have the rows first. So think about the rows first, then you think about the column, all right? Not the bigger number in this context for now. Now, again, what is the name of this matrix again? Can anybody tell me? And make sure you're using the right thing, okay? It's not a common B or a lowercase b. What should it be? Yes, put on those cap lock. All right, cool, nice. So it's B, capital B. So could anyone tell me what do you think the order of this matrix would be? All right, I'm seeing 2 by 3. All right, cool. All right. So we would have distinguished or made the we would have discovered that matrix B has 2 rows and 3 columns. So how would you write that? As what I'm seeing in the chat so far. And how do we say that? An individual would have said that earlier, 2 by 3. All right. So it's not 2 multiplied by 3. We generally say 2 by 3. That's how we say it in our math language. Remember, English has a language and math also has a language. So we want to be consistent with that language that we're using. All right. Is everybody okay with that? That's fine. I think that's cool. All right. All right, nice. So let's continue. All right. All right. Now the elements. Remember the entries that we would have made mention of. So each of the, oh, you're still writing? You can take a screenshot. You can take a screenshot or a picture. Or you can always go back to the YouTube recording and then, stop it and then write and then continue. All right? All right, Bartley from Kingston Tech. You can always take a picture. All right, fine. All right. So we have in this matrix, are you seeing anything that you want, anything of note that you're seeing in this matrix? And by the way, what is this matrix called again? What is, okay, A. All right, cool. All right, anything else that you're noticing with this particular matrix? Anything, do you notice anything with this particular matrix? The subscripts, all right? Anything else that you can tell from the subscript? Anything else that you're seeing? Anything that pops out to you while looking at this matrix right now? Okay, it's a 2 by 2. Good, 2 by 2 matrix. All right. Anything else? You're not seeing anything else that you might think about using? All right. So what about A11? you have to ask yourself, what does 1, 1 signify? What does 1, 1 mean? So the rows are counting by the 1, by 1, same for the columns. All right. And when you want to look at 2, 1, 2, 2, and 1, 2. So A1, 1, A2, 1, A1, 2, A2, 2. Okay, you said each column is adding by 10. Interesting. Interesting. That is something that you actually, that I am just seeing as well. So that's all right, fine. So the first element in the first row, what is that? What's it? Shanika Brown? First element in the first row. What is that? Oh, A11. All right, cool. The number tells this first element in the first row. All right, we'll speak about that in a bit. So let's see. Thanks again, everyone, for sending those messages in the chat. So let's continue. Let's see what we can make from it. So A11 means that this entry or this element is in which row? Which row is it in? A11, which row is it in? That's the first question. Which row is it in? The first row. All right. And what column is A11 in? It's in column 1. So that's what A11 means. That's what the entry at element means. All right. So let's do it quickly. What about A12? What will that mean? That entry for the rows. For the row. What row is A12? All right. Row 1 or the first row. What about the column? A12. Column 2. All right. What about A21? All right. Which row is it in? All right. Second row. And again, remember, emphasis on that row first, then the column, because it will come back when we're doing some operations. All right. What about the column? A21, first column. All right. And finally, A22 means what? What is happening to the entry in the row and the column? What's the row? Second row. Nice. And then the column. All right. Nice. Cool. All right. And don't be afraid to, raise your hand and open your mic and speak, right? Sometimes I want to hear other voice besides myself and my colleagues every now and then. All right. So that is indeed A22 means second row and the second column. All right. Go, Mac. Oh, McLean. Oh, I thought you were going to talk. All right. Now let's consider this matrix. Our first little actual activity, even though we were working some examples, etc. So we have matrix M. And so what is the name of the matrix? And we now write in the chat or say in the chat. All right, M. Good. So what's the number of rows in this matrix? All right, 3. And what is the number of columns in this matrix? Okay, 3. Nice. So what do you think the next question could be or would be? What is the next question? What do you think the next question is? Our next statement, I should say. Oh, Clark, you can go ahead.
What's the order of the matrix?
Okay, good. So everyone was giving me the answers, but you actually gave me the question. Nice, love that. All right. So it's actually not looking for the answer for the next question, but actually what was the question I'm going to ask. So he mentioned the order. Another word you could use, it should be dimensions and all of that. So it is a 3x3, as most of you were giving in the chat. All right, what about element M21? What is that element? Element 21. What is that entry? All right. 21. So what does the 2 represent again? What does the 2 represent? Oh, you corrected yourself. All right. So the 2 represents a row and the 1 represents a column. So you want to go for the second row. Look in the second row. So this is row 1, row 2. So you look in the second row and then column 1, which is 4. All right. So yes, you corrected yourself, but just in case someone else would have made that a similar mistake. So it is indeed 4. What about element 23? Element M23 or the entry M23. All right. 6. All right. Cool. Nice. You're following and paying attention. What about element M33? M33. All right, subscript M33, or lowercase M33. All right, nice. Okay. Now, let's observe these two matrices, I should say. So again, so we have matrix P and we have matrix M. Now, do you notice anything? Are there any similarities between the two matrices? Is there any difference between the two? And once you're stating 1 by 2, etc., you'll have to tell me which matrix you're making reference to. All right, once two individuals, or three, well, 5 individuals would have said 1 row. So both of them have 1 row. All right, Ricardo Plummer just cemented that for us. So yes, it has 1 row. But okay, I know I see negative numbers, technically. All right, so what would be the order of matrix P? Okay, I see Shanika Brown gave me everything at once. So what is the order of matrix P? 1 by 2. And again, all right, cool. So the order of P is 1 by 2. So how many columns does matrix P have? How many columns? All right, 2. So you're paying attention. What about matrix M? And I never asked the question yet. So what about matrix M? It's not a continuation, but how does it have 1 row, 2 row, 3 rows? How many rows does matrix M have? All right, 1 row. All right, cool. And the order, everyone was typing in chat, so I just had to reveal. So the order of M is a 1 by 3. So that is actually, these two matrices is an example of a row matrix. So a row matrix only has only one horizontal line of elements. All right? So only one horizontal line of elements. All right, let's see if you can give me a row matrix in the chat. Use your brackets. Just give me an example and remember to name your matrix. So matrix, and then give me an example of a row matrix. Can you give me another example of a row matrix in the chat? Okay, and remember, emphasis on labeling or naming the matrix. All right, cool, I'm seeing a good amount of them. I'm satisfied. So that is indeed a row matrix. All right, what about these two matrices, matrix A and matrix C? Matrix A and matrix C. Do you notice anything, patterns, any similarities? Anything that you can take from both of these matrices? Matrices A and C. Does anything come at you? All right, sorry, I was scrolling down. All right, so Ricardo Plummer again is on the ball saying both has only 1 column. So what is the order of matrix C? What is the order of matrix C? Matrix C, what is the order of matrix C? All right. So remember, rows come before columns. So it's not 1 column and 3 rows. It's 3 rows by 3 by 1. All right. So you want to put emphasis on the 3 by 1 or use the symbol that we use. What about matrix A? What is the element in the second row, first column? What is the element in the second row, first column for matrix A? Yeah, I caught you there. All right, so I wasn't asking for the order. I was asking for the element, and it is indeed 10. And the order, no, the order of matrix A is? And what is the order of matrix A? All right, nice. So let's carry on. So we did a row matrix. So what do you think, or what could you decipher now for this one? Does it have a special name, these two matrices? A column matrix. Could you give me a definition for column matrix? Could you give me a definition for, yeah, go ahead, McLean. Oh, McLean, you want to talk? Latavia McLean? No? You can type in the chat quickly, or you can raise your hand and open your mic. Okay, nobody wants to do that right now. So a column matrix only has only has one vertical line of elements. All right. All right. So you're just basically doing the same thing, but you just would have taken out horizontal and used vertical. All right, and I'm seeing another one by Williams. A column matrix is a matrix that only has one column and can have infinite number of rows. Infinite, something that you should remember from your primary or prep school days. All right, and I see that you're using the math language. So that is indeed spectacular. So a column matrix only has only one vertical line of elements. All right, so thanks everyone for giving me a swift responses. You had to type out a lot, and it is indeed column matrix. All right, let's push through. So we have, right, a column matrix is also called a column vector, is a type of matrix that only has one column and multiple rows. All right, good, Rashida. So instead of multiple, we could have used infinite, or instead of infinite, we could have used multiple. All right. So we have a scenario. I don't know if anyone plays cricket or likes cricket, 2020 cricket, etc. Not so much of the fan of the ODIs or test crickets, but we have a scenario right here, or a task or activity. So We Care High School participated in a cricket tournament against schools A, B, and C. So the coach prepared a table to show the number of runs made by his top 3 players in each match against the 3 schools. So this is a table. So we have the table and we have the players' names. We have Sean, Joshua, and White. All right, and we have school A, school B, and school C. Now, you might be wondering again, or some persons might say, oh, sir, miss, why do we need to learn about matrix or matrices in general? We're not going to see it again after we finish high school and tertiary or college. But your coach or a coach at this particular school is using or is going to use from a tabular form into a matrix form. All right? So this is just one application of the many that matrices we can do with matrices, especially with IT, information technology, and computer science in the upper grades. So we want to represent this information above as matrix X. So that's what we're going to get at right now. And we have a good amount of questions. We have 3 other questions. So again, the table is on the top right. So you don't have to worry about writing it off on the previous slide. You could just take the screenshot right now. So we want to represent the information above as a matrix X. Now, okay, we have a matrix X. All right, we'll have our enclosed curve brackets, all of that. Now, what about the elements? What would go where? What are the elements for the first column for this particular matrix? Just having it. What are the elements in that? Okay, I'm seeing 10 for the first column. I'm seeing 10 so far. Column. Did I mention column or row? Which one did I mention? Okay, I did say column. All right. So So technically you can't write it, but in the chat, but I see Miss Crawford tried, even though he used multiple brackets, but I get your point. So it would be 10, 89, and 43. Those are the elements. All right. So you wouldn't technically write them in a brackets because it might be a row, right? Row matrix, and we want a column. So we have 10, 89, 43. What about the elements in the first row? Elements in the first row. What would be the elements in the first row? First row. Elements in the first row. All right, good. All right. So we should be able to write our matrix. And I hope you actually wrote your matrix X in your book or on your sheets of paper or plain papers. All right. So I'll give about 10 seconds to try to write your own, the matrix X represented by the table, and then we'll continue. All right. Now I hope that this was your actual matrix that you got, and you have and you had all of the elements correctly. So you can say, yes, I got them. Or you can give me a thumbs up to say or indicate that you actually, all right, cool. Yes, that's fine. Yes. The recordings are the recording will be on YouTube. So technically you are late, but you're not late for learning at your own time when you're ready. All right. So yes, good. So a good amount of persons, at least 12 or 13 individuals would have stated that they got them correctly and all of the entries are in the correct positions. Now, in the information in this matrix, in matrix X, what is shown in the column 2? So we're on to the second question. What is shown in column 2? What information is in column 2? What information is shown in column 2? Yes, the 20, the 50, the 10, but what does that, what are those entries saying to you? What do those entries mean to you? Not just the numerical values, but what do they mean to us? Even number, they're even numbers, but as it pertains to the context of this matrix and this table, what does column 2 represent for you? The most runs from school B? Is it from school B? Let's look at the scenario again. So let's look at the scenario. So we have the schools. So against A, B, and C. So the top 3 players from Week Year High School, this is the amount of runs that they would have made against School A, School B, and School C. All right? So we're trying to find out what information is shown in, or what is the information our entry is telling you for column 2. So School B, what about School B? The number of runs made against School B by what? By the 3 players, by the top 3 players. All right? So that's what it means. So you would have partially said it in the chat and just mentioning it again. All right? So it means the runs scored by the top 3 players against School B. And somebody said the number of runs the top players from Week Year High School made against School B. All right, good. And they're using the English language, writing your statements and, well, writing your sentence. All right. What about the third one? All right, good, Linda and Kellyanne Williams. What about the third question? Explain what element at position X31 represents. What is X31? That's the first thing that you want to get. What does that entry element, what is the numerical value? So X31, we're saying 43, all right? And what does that tell us? What does the 43 give us? 43 runs were made by White against School A. Good, Shanika Brown. Anyone else has saying the same thing, but it's worded differently? All right? So again, 43 runs were made by White against School A. All right, 43 runs that Wyatt made. And again, remember, against School A. You have to write that part or have to say that part, Sherika Blair. All right? Is everybody cool with that? Oh. Okay. So how I got 43 quickly? So the 3 represents a row and the 1 represents a column. So we look for, this is the first row, this is the second row, and this is the third row, and this is the first element in column 1. All right? So that's how we got it. That's how we got it, all right? Giovanni Thompson, that's how we got it. All right, cool, nice. All right, you're welcome. All right, what about the element number 4, question 4, the element 89, what does it represent? Okay, the number of runs Joshua made against School A in the cricket match. All right. 89, all right. All right, everybody's getting the gist. The element 89 is found in row 2, column 1, meaning it represents Joshua's score against School A, not in game A. It's actually against School A, all right? So just, you can fix up that at the end, Anna K. The number of runs Joshua made against school A. All right, cool. So we actually can tell what information in the matrix represents. So it's not just about the numerical value, but how we can go into it a bit more in detail. So again, this is just another way that we apply matrices in our, not in your everyday life. You might not be a cricket coach, you might be a coach of something else, or you might be an accountant, etc., IT, whatever your future, your career path would be. All right. So again, we would have said that Sean would be the first row. So 10, 20, 21 would be Sean's scores for against school A, B, and C. So what would the second row represent? Which player would the second row represent? Which, okay, Joshua. And the third one? And the third row? All right, cool. Yeah, so that's it in literally about 10 minutes, all right? So yes, we're on the right track. So again, these basics are what we'll be using for the other aspects of this presentation of matrices. Now let's go to the concepts. We actually did some concepts, which was a row matrix and a column matrix. All right. So those are actual concepts, right? So let's explore more about the concepts. Is everybody with me? Are all 234 participants with me? And even my colleagues, are you all with me? Okay, yes, okay. Yes, all right, cool. All right, let's push. Oh, go ahead.
I was just answering and saying, yes, sir, we're with you.
Okay, okay, yes, that's what I love to hear. All right, let's continue. So, all right, so we have, what is this matrix called? What is this name of this matrix that we have in front of us on this blank, kind of blank screen? What is it called? What is that matrix called? All right, and somebody would have went ahead and said square, but okay. But the name of the matrix, notice the question that I asked. What is the name of the matrix? Nothing else was asked. I would have never said the type of matrix, nor the dimensions. All right? So again, when you get the questions, read the questions carefully and make sure you're actually answering the question. So the matrix is called G, and yes, it's a capital G. Now, how many rows and how many columns do we have? First, rows first, then columns in this matrix G. All right, 3. And how many columns? And everybody's giving me the dimensions. Okay. All right. So everyone said the dimension. Now, do you think, just by looking at this matrix G, do you think now, is G a square or rectangular matrix? So that's a type of matrix now. Is the matrix G a square matrix or is it a rectangular matrix? What makes it a square? What makes it a rectangle? You tell me. Okay, Christina said the same amount of rows and columns, the same number of rows and columns. A square matrix is a type of matrix that has the same number. So emphasis on the number, not the amount, the English language, and I hope my colleague can back me up on that statement. So, all right. So square means it's equal, but you have to say equal in what regard? All right. So it has to have equal number of rows and numbers of column. All right, good. So a square matrix has the same number, emphasis on the number of rows and columns. So you would have discovered that it has the same number of rows and columns, which is what? Which number is it? Which number is it? The same number of rows and columns for matrix G. Which number is it? 3, the lucky number 3, top 3. All right, cool. Now, matrix G is an example of a square matrix because it has 3 rows and 3 columns. So if we said that that's a square matrix, what would be a rectangular matrix? Can you give me a definition for a rectangular matrix? Oh, one of my colleagues will mention that in the chat. Okay, you give me an example. Okay, a 3 by 4, a 2 by 3. But what makes it a rectangular matrix? What makes it a rectangular matrix? Yes, those are good examples of the dimensions of a rectangular matrix. But what really, in definition, a matrix that does not have the same number of rows and columns? Okay, so the number of rows and columns would be different. So that's a rectangular matrix, right? So again, it's that easy. Once you have an example, you can actually make up your own definition, right? It is your opinion, and once you have stated it correctly, in whatever jargon or so, but it must be mathematical, of course, and you will get that, you will be awarded that mark or marks, etc. All right. All right. In a rectangular matrix, the number of rows and columns are not the same. All right. And we would have, some individuals would have given me examples of such. All right. And that's fantastic that you could have given me the dimensions and all of that. All right. Let's move. So again, this is another example of how you can apply matrices. And you don't have to be an exam coordinator. You can be some coordinator in a BPO industry, at CariMed, whatever business or other agencies are out there. Of course, there are many, but I'm not listing them right now because that would take us more than the 12 o'clock. So again, this is another application of how we use matrices. So at your school, you have an exam coordinator. And notice the question or the scenario never really said, it's not asking you to say, oh, you have an exam coordinator at your school? No. You want to stick to the question and not taking it too out of your imagination. Stick to what the question is asking you to do and what the scenario gave you. So at your school, the exam coordinator records grades, and we would have classified that as matrix G for 3 students in 3 subjects. The 3 subjects are mathematics, English, and economics, respectively. So notice it now says, it kind of gives you a hint. It says the grades for a student is written in 1 row. And how many rows did we have in matrix G earlier? All right, cool. So that means we have 3 students. And how many columns did we have? 3 columns. And what will the 3 columns represent? Would it represent the 3 students or the subject areas? What would the 3 columns represent? Is it the students or the subjects? Which one? The columns, the subject areas. All right. And thanks, Ms. Harris, for making that connection with the properties of the square and rectangle. Thank you for that. All right, so let's go. So we have G, matrix G. So what number is at A23? And by the way, is A23, should I have A23? What should I really have right there? Let's see if anybody is on the ball or thinking. What should it have been? All right. And remember, it's not a capital G. It's a what? It's a common letter G. So yes, it should be G23, common letter, of course. Good. That shows me that you are paying attention. So it's not G to the 23rd, right? So the G23, subscript. It is not a power, right? The 23 is not a power. It's not an index. It's not a base raised to a power. All right, so you don't write it as 3 to the 23rd power. All right, so that should have been G. But carry on. What number is that G23 though? What number? Okay, I'm seeing a 72. Right, 72. And again, what does that 72 mean? What does it actually mean to us? What does it mean to your exam coordinator, that grade of 72? What does it represent? That's the question that you really want to ask. It's not just about numerical values, but what is the information of the 72? What does it mean? All right, which student? There are 3 students. Which student? Which student? Which student? Okay, the second student. That's the first thing that we want to get out of the way. The second student. So let's label it. Let's do a little labeling right here. So this is in the second row. All right. So it's a student 2. Again, I apologies for the bad handwriting. I write like a doctor. So that's student 2. But what does the 72 in the column represent? What subject is it referring to? The grade that student got 2 got in economics. Is it English or economics? Which one is it? It's econ. Yes, it is. So where would English be? Where would English be? The first or the second column? Okay, English is the second. Now what about maths? The lovely maths that we're doing right now. Which column would that be in? First. All right. So what in the question actually dictates or tells us that this is the proper order and not English, math, econ? What in this statement or scenario, what word or what term respectively? See, you see how important that English language is? And yes, we're doing math, but that English is so crucial. That word respectively indicates that the first column would be math, the second column would be English, and the third would be economics. All right? So you have to be careful of that. And we'll get to more examples of that as well. All right? So that is indeed what it stands for. So student 2's, the student 2 grade in economics. All right? So what about 68? What does, sorry, not 68, 67. What information is 67 giving us? How would you read that and tell somebody, oh, that's 67, it means, yeah, what would you say? What does the entry of 67 mean? Student 3 got 67 in English, right? Or you can say the grade, the English grade that student 3 got, whichever way you want to phrase it, as long as it's bringing out the actual answer, all right, our solution. All right. All right, good. All right. So everybody's cool with that? Everybody's on the same page? We can read a matrix, understand what each elements mean, and apply it to a context or a scenario right now. Is everybody cool with that? Thumbs up, thumbs down? I don't know.
Yes, sir.
Whichever way. Okay, nice. Fantastic. And thanks for speaking. I thought I was the only one in the room. All right, let's move. And it's 67, not 67. All right, 60. So on that 6, you should have a TY. Yeah, so it's 67. All right, not 67. You don't say that, it's 67. All right, so let's move. Now, knowing an exam coordinator, I shouldn't really be doing this, so let me stop. The exam coordinator has now included Spanish grades for each student. Now, will the Spanish grades be entered as a row or is it as a column? What do you think? Is it a row or a column when I input those grades? Both. Why did you say both? Could you expound on that, Crawford? Oh, okay. I think no, you haven't. Crawford, could you expound on that? All right, and somebody made a key term. Shani, sorry, I'm pronouncing your name wrong. My apologies. The number of students stay the same. That's important. All right. So the subject areas are the columns. The column will change. That's where the data will be entered. My bad. So can anybody tell me, let's just say, now we have that matrix H. Can anybody tell me what grade student 2, what grade did they get in Spanish? Okay, student 1, what grade did they get in Spanish? And student 3, what grade did they get in economics? So here, it's not Spanish this time, it's economics. So again, look at the question and make sure you're answering. Now, because you're giving something new doesn't necessarily mean you'll get a question straight out of the bat. All right, we can change it. So 78 is student 3's grade in economics. And as a young lady would have mentioned, that the rows stay the same. And you're seeing that the rows stay the same, right? So how many students do we have? Do we have 4 students or do we have 3? All right, we have 3 students. And how many columns do we have? And how many subject areas do we have? Okay, can you give me the subject areas in a list? You can shorten it, by the way. You don't have to write out the entire subject areas. Could you give me the subject areas respectively? You can open your mic and speak, or you can just type in the chat quickly. Math, English, economics, and Spanish. Good. All right, what about the dimensions? Did the dimensions change? Okay, what is the dimension now? Okay, 3 by 4. But remember that we had G. Was matrix G, did we say matrix G was a square matrix or a rectangular matrix? Matrix G, did we say it was square or rectangular? Okay, so now that we have this new column, is this still a square matrix? Is this a square matrix? Okay, it's a rectangular matrix. All right. So again, properties of the rectangle, the length and the width, or the sides would have the length and the width, the dimensions would have different size. And yes, a square will have same sides. All right, cool, nice, rectangular. I would have asked this already, so I don't have to ask it again, but I was forward thinking, right? All right, and yes, I can see the future. All right, let's go. So as we said before, the rectangular matrix, the number of rows and columns is going to be different, of course. All right, we have a 3 by 4, so the number of rows and columns are different. They're not the same. Yes, you see, you can't complain now, you know. You really can't. You can't complain and say, oh, Miss Sir, it's just a lot of data. It's not just a lot of numbers. Oh, it's just going to help us. Again, another scenario at your school as IT students, as information technology students. They are exploring how computers store and process data using binary codes. The teacher shows how a computer system might use a binary matrix to represent the data. Now, does anybody remember the digits that we use for binaries?
1 and 0.
Yeah. Okay, 0 and 1. All right, cool. So we have, what is this matrix? What is the type of matrix that we have right here? What is the type of matrix that we have right here? All right, square matrix. All right. What about this other matrix I? Okay, square. All right. 3 by 3. All right. Are you noticing anything with this? Are these two matrices I, labeled I? Do you see anything? Do you notice any patterns, any similarities? It's an identity matrix, but matrices, but how do you know? Okay, the leading diagonal is 1. You see 1s and 0, which is binary. All have 1 going diagonally. Okay, so we have an identity matrix, which is a special square matrix, all right? And each element on the main diagonal, which was referred to earlier, top left to the bottom right is 1. And what are the other elements in the matrices? Zeros. All right, so that is the leading diagonal, top left to bottom right. That's in the first matrix. And then the other one, same thing. All right, and the other elements are zeros. Now, what about matrix Y and Z? Are those said to be identity matrix? How do you know? Okay, all right. All right, Y, first one, Y. Is Y an identity matrix? How do you know? How do you know that Y is not an identity matrix, or is it? Oh, because the leading diagonal is not 1. All right, so the leading diagonal is not 1. So we have that right here. So that is indeed incorrect. So Y is not an identity matrix. What about matrix Z? Is that an identity matrix? No. All right, cool. Why is it not? All right. Why is it not an identity matrix? The leading diagonal isn't 1. All right, nice. What about equality? So John uses a row matrix to enter his 2 homework scores for September. Now he would have completed another row for his October scores. Now, how many rows will we have in this matrix? In this matrix that we'll develop? We're saying 3. Is it 3 or 2? How many rows will we have? All right, how many columns would we have? All right, let's see if you are correct. So these are John's grades. So 175, 175, 90, 80. Now, which one of these grades represent the September scores? Sorry, the September scores, not grades. What are the values for the September scores? Okay, 175. Not 175, but yeah. All right. And the October grades would be 90, 80. All right, so he has a friend who has the identical same scores. So would we have the identical elements now in Sean's matrix or the matrix S? Yes or no? Would it have the identical? All right. So how many rows will Sean's matrix have or S have? How many rows? 2? How many columns? All right. So yes, it is indeed showing that. So if we should compare matrix J and S, what will we have? What do we notice? Okay, they're identical. In other words, they're going to be equal to each other. So 2 matrices are equal if corresponding elements in the matrix position, in the matching position, having the same value, and therefore also know that the order is the same. All right. So matrix J and S are identical. All right. So that speaks to equality. All right. So both of them are equal. Is everybody cool with that? Thumbs up.
I have a question.
Oh, go ahead.
For the students. The numbers 90 and 100, who can tell me what those numbers represent? 90 and 100, what is that saying?
All the grades from September.
Go ahead, Clark.
It represents his grade, John's grade for September.
All right, let's read again. John used a row to enter his 2 homework scores for September. He used a row. Row goes across, column stand up like the column in your house. So he used a row to enter his 2 homework score for September. So his September score would be 100, and the second one is 75 because they said there were 2 homework scores for September. And then he completed another row for October. So the 90 and the 80 is his October score. I'm now asking you, what is the 100? If I look at the 100 and the 90, what is that telling me?
The first homework scores.
The 100 is representing his homework score for September, while the 90 is representing his homework score for October.
All of them are homework scores, you know. So the 100 would represent
The
his
first
first
homework
homework
score?
score for September, and the 90 would represent his first homework score for October. Let's go again. 90 and 100, one is for September and one is for October. The first one is his first homework score for September, and then the 90 is his first homework score for October. Somebody else had their hand raised, Mr. Limi?
Oh, I never saw. I think
Okay,
it was
so I'm
Clive.
going to ask another question now, which is the obvious question. What does the 75 and the 80 tell us? Who wants to talk
The
about
second homework score for September and October.
that? Right. That makes sense now. Okay, so the row is for the month. Each row is for a different month. But the column is whether the homework score was the first one that him do or the second one. Thank you, Mr. Limi.
You're welcome, and thank you too. All right, thanks for that bit of information.
Just want to
Campbell?
congratulate Christine.
Oh.
Christine Britton actually said, when you asked about the 190, Christine Britton actually typed in the chat, his first sets of homework grades, both October and September. So, well,
Beautifully said.
She stated it as his first set of grades, which I think is what you were listening out for, correct, Mrs. Darby?
Yes. I say Campbell had a hand raised. Campbell wanted to say something? Okay, back to you, Mr. Limi.
All right, thanks much. If you have more questions, you can always refer to the chat, and my colleagues are more than able to assist. All right?
Sasha is asking some questions.
Sorry.
Sasha, you want to open your mic and say and ask your concern?
Sasha Cooper. All right. No, I guess not. Oh, she says no. All right, so column 1, what information will column 1 give us? Remember, you have 2 homework scores entered for September, and those are in the row matrix. And what did we say about a row matrix? All right, technically speaking, it will be this particular row. So these are the 2 homework scores for September. So Miss is asking, the first row, or Miss mentioned, sorry, the first column, what homework does this represent? The first homework or the second one? So which is it? The first homework or the second one? That speaks to column 1. So that's the first, I'm going to write HW for homework. And then the second column. Oh, go ahead. Okay. All right. And then the second one. So when Miss would have highlighted the 100 and the 90, someone would have given the answer. Those are the first homework grades for the months of September and October, respectively. All right? So that's what Miss was highlighting based on the individual's response. Okay? Is that okay now? Who was it? Sasha Cooper and Alice. You would have typed in the chat a bit. Is that okay? You can open your mics or you can just type quickly. Okay, cool. So that is how we want to analyze the matrix, right? Again, as I said before, it's not just about numbers, numerical data, whatever. Once you have the context, you want to apply that context of this question or scenario of this question into the matrix. All right? So the first row, 100, and the value, the entry of 75 represents what? What does it represent? The 100 and the 75 for the first row. What does that represent? Let me shorten it a bit. Does it represent September grades or October grades? Okay, the grades for Well, it's really the score, it's not grades, but yeah.
September.
Yeah, all right, cool. And then the second row, the 90 and the 80, what does that signify or represents to us when we're using this question or scenario? October's
October.
scores. All right, cool. All right, so that's what we were getting at. All right, let's move. All right, thanks for bringing out that. So if any other values, note that if any other values is different, the matrices are not equal. Now, scalar multiplication. So the Ministry of Education used a matrix to show the number of books, tablets, and computers it sent to 2 schools. So we have E to represent the information matrix E, and it's given by the elements in the matrix. Now, how many schools do we have? What represents the schools? Is it the row or the column? What represents the schools? Is it the rows? Okay. And something that you can also use is the amount of items that you have. It says 2 schools, and how many columns, how many rows and how many columns do we have? We have 2 rows and how many columns? How many columns do we have? We have 3. So you want to be using information like that as well, or could use information like that. So for the columns, what information is represented in the columns of this matrix E? What information is given by the columns in this matrix?
Tables and computers.
Oh, I don't know if you broke off when you said books. I hope you would have said books, but I think that's what you said. So the number of books, tables, and computers. All right. All right. So the first school got 74 tablets and 5 computers. All right. How many books, tables, and computers did the second school get?
81.
Oh, go ahead.
98.
Oh, go ahead.
You're saying tables, make that correction to tablets.
Oh, tablets. Oh, my bad. Thanks. Thanks. Sorry again, everyone. How many books, tablets, and computers did the school get?
98.
All right. What represents 90? Is it the books, tablets, or computers? Okay. What represents the entry of 2? The entry of 2. So that's 2 what? 2 computers. And which school received the 2 computers?
The second school.
All right. Now, the ministry plans to double the number of items it gives to each school. So doubling, what do you think will happen to the matrix E now? What do you think will happen to the matrix E? Multiplied by 2, what is going to be multiplied by 2? Can you tell me what will... The brackets? You mean the enclosed curve brackets? The brackets is multiplied by 2. I have 2 brackets, so I multiply 2 brackets by 2 and get 4 brackets. That's what you're saying to me? What is...
Multiply everything in the bracket by 2.
Is going to be multiplied by 2. Each element... So 2 is multiplied by the first row, first column. What element is in the first row, first column that I will multiply 2 by? What element? Or 100. All right. What am I going to multiply 2 by? The 2, I'm going to multiply the 2 by the element in the second row, third column. Which element is that? Okay. And that means computers for the second school. So we just multiply 2 times 100 is 200, 2 times 74 is 128, 2 times 5 is 10, and the rest is history. All right. So 162, what does that information tell us? What does 162 tell us?
The number of tablets given to the second school.
All right. Again, it's not just about the number of tablets, but delivered to the second school. So that is a part of your answer, right? It's just not about the amount of tablets. It should be the number of tablets given to the second school. So scalar multiplication is each element in a matrix is going to be multiplied by the same number, which we have are called the scalar. You might have done integrated science or physics or doing those subjects. Can anybody tell me what a scalar quantity is or what is a scalar? What is a scalar? Go ahead. In other terms. So it has just magnitude. What about vectors? You might not do it already, but vectors has both magnitude and direction. And once you get to vectors, the topic of vectors, you'll see that as well. All right, nice. Magnitude and direction. All right, sorry about that. So the other one is addition and subtraction of matrices. So we will be doing those operations for matrices as well. So addition and subtraction, and then multiplication thereafter. All right, so that's a slide. All right, that's fine. All right, so adding and subtracting matrices. So we want to ensure that we follow the steps and use the steps accordingly. So ensure that the matrices are going to be
One moment, sir. Sorry for the interruption. Bartley is asking if you could go back for 1 minute. I'm not sure. Bartley, could you be more specific?
did.
Where would you? Oh, you
Oh.
did. Oh, sorry.
I did go back to, I think it was this slide. That's the only slide that I went to before. Anything else, Bartley? Oh, to this. Oh, okay. Sorry about that. Thanks. It's,
Just a
You're
gentle
welcome.
reminder as you move on, sir,
Oh,
that we are live on YouTube. So if you miss something now, you can always rewatch the video in your own time.
all right. And thank you as well for the comments that were made in the chat about the 74 times 2. Yes, it should have been 148. My apologies. All right. So again, for the individual who would have just took the screenshot, I am imploring you to take it again, please. So that should be 148. All right. And thank you for paying attention as well. All right, the link will be placed in the chat in a short while. All right, let's continue. Let's see what we have. All right, good, nice. All right, so when adding or subtracting matrices, we want to ensure that the matrices are compatible. What does that actually mean? They must be the same size, same order, or same dimensions. So that's one thing that we want to ensure that we have. And the second condition would be just adding or subtracting the corresponding elements or entries that we have in each matrix. All right, so those are the two steps that we want to carry out and follow through when we're adding or subtracting matrices. Is everybody okay with that? Is that clear? Well, it will be clear when we do the examples, but yeah. Is everybody okay with those two steps or two conditions so far? All right, nice. So for example, we have two matrices, sorry. We have A and B. All right, good. Okay, we have A and B. So we have matrix A and matrix B, and we have the elements. And by the way, this topic of matrices will be on a standardized test that you will be getting before the year is finished. And we'll provide more information as it pertains to that as well. And I know your teachers, your mathematics teachers at your schools will also indicate such. All right. So we have the two matrices and let's add them. So remember now, we seek compatibility. they must have the same size or the same order. So matrix A, what is the size of matrix A? What is the size of matrix A? Can anybody tell me? Okay, a 2 by 2. 2 by 2, not the type. I never asked for the type, I asked for the size. So it's a 2 by 2. What about matrix B? It is also 2 by 2. So are they compatible? And yes, they are compatible. And then the next thing is we need to add the corresponding or add or subtract the corresponding values, but in this circumstance, we're going to add. So are we adding the corresponding elements in both of the matrices? Are you seeing that? For the first column, what are we adding? A11 to what? First column, A11, what are we adding A11 to? Oh, B11.
B11.
All right. What about A22? What will we add that to? Okay. All right.
B22.
Good. Fantastic. What about A12? What will I add that to?
B12.
What about B21? What will I add that to? B21. Okay, A21. So again, you want to make sure that you're doing the corresponding elements. In other words, you're matching, right? So once you find out they're compatible before you add or subtract, and even when you multiply, but we'll get onto that shortly. So you want to check the compatibility of the matrices that you're adding, subtracting. All right. And then once you do that, you're going to add or subtract the corresponding elements. So technically, it's the same thing for the subtraction. The only thing is that you actually have a minus sign or a subtraction sign between the corresponding elements or entries. All right. Is that self-explanatory? Is everybody okay with the conditions and the steps necessary to add or subtract matrices?
Yes, sir.
All right, nice. And you can take that picture and then you can always put a plus or minus, etc. to remember what you're actually doing. All right. All right. 5 seconds. 1, 2, 3, 4, 5. Let's move.
All right, so raise hand.
Oh, who has a raised hand?
I think it's Shanine.
Oh, so what if they aren't compatible? If they aren't compatible, then you can't add them. You can't subtract them. In other words, I'll give you an example. Let's say we have a 2 by 2 matrix and we have a 3 by 2 matrix. Do these have the same order? Does this matrix compare to this one? Do they have the same order? No. So you can't add or subtract them. All right? So you can't add or subtract once it does not have the same compatibility. So thanks for that, Giovanni Thompson. So that is why you can't add or subtract. All right? And that's a point to everyone else. All right? So a coach wants to examine the number of runs made by his 2 best players from Week Care High School in a cricket tournament in the first and the second innings. The opposing schools are called A and B. So we have this in the table and emphasis on what the title of the table is, which is the runs made by the 2 players in the first innings. So we'll be formulating a matrix. So quickly, 5 seconds, formulate a matrix for this one. I'll call it X. So we call this matrix X. I want you to formulate a matrix based on the table, and then we'll see or reveal the slide to see if we got it right. So 5 seconds. All right, let's see now. So did we all get this? Yes, 71. Did we all get this now? And it's not 77. I noticed someone said 77. It's 71. 40, 71 first row, 30, 50 second row. So we want to make sure that we actually have the correct values and check over. Just like what I forgot to do. Always check over. All right. So what does 11 mean? Who said that? Does 11 mean? Oh, what's it? Twin needle?
Mr. Limi, I think he was asking about the the subscript in the previous matrix right. What does the subscript 1-1 mean? So somebody must have come in late and didn't quite get that.
All right, so 1-1 indicates the rows goes first and then the columns. So A11, the first number is a row, and yes, where persons in the chat are actually helping, and 1 column.
So it is telling where the matrix is. The element, sorry, is. So the element is in row 1, column 1. And
All
1,
right.
2 says it is in row 1, column 2. So the one beside it on the right, where it says 1, 2, it is saying it is in row 1, column 2.
1.
So the subscripts are the location where it is.
The positions of the elements are entries. You're welcome. All right. So do not be afraid to type your questions in. We always have individuals helping, whether it be our colleagues or even the students who were here earlier could attest to that, or they can assist. All right. So first row represents Sean's runs, and Joshua is the second row. So this is now for the second innings. So I want you now to make a matrix, and that matrix must be called matrix Y. So write the matrix Y based on the table now. You might think it's a different table, yeah, but it has different values now, different numerical values or entries for our matrix. So I'll give you 5 seconds to write down matrix Y. And remember, X and Y, we'll be using them shortly. So make sure you have the X and then you have the Y. So 5 seconds have elapsed. So did we all get this matrix Y? Yes, no, thumbs up, thumbs down. All right, nice. And just for emphasis, what was Sean's runs, the runs that he made against School B? What was that? What was the value? The runs made by Sean against School B in the second innings. I never said first or second, so good point there on the answers. So again, yes, good. So at least you asked that question. Is it the first or the second innings? All right, good. I would have never finished the question, but yeah, that's good that you can point out that. All right. So now we want to determine the total number of rows made by each player against the school using the matrices formed previously. So what 2 matrices are we referring to? What are the names of the matrices that we had for the first and the second innings? What did we call them? Remember, capital letters. I know that you're using your phone and you might not capitalize it, but at the beginning you should capitalize, right? So X and Y, capital letters. So again, for the persons who would have came in late, capital letters are what we use to denote matrix. All right? And the elements or the entries are common letters once we don't have any numerical values. So we have these 2 values. So what's the first thing that we do before we add or subtract? Let's see who is thinking. Let's see who remembers. What's the first thing that we'll do? All right, check compatibility.
Compatible.
All right, compatibility. Or we find the dimensions, which would give us our compatibility. So matrix X and matrix Y, are they compatible? Do they have the same dimensions? So can we add or subtract them? Okay. Now, we're doing adding or subtracting, but we're not going to do both for this one question. So what word in this question tells us that we need to either add or subtract? Total. So total means that we need to what? Add. So that's what we're going to do. Add X and Y. So we check the compatibility. So we have the matrix X and the matrix Y, and we're going to add them. So what's the second thing that we do? What's the second thing that we do? We check the compatibility. What's next? Add what? Add what? Add what? Group them. What do you mean by group? Group them how? Group them how?
Add the corresponding elements.
Add the corresponding elements or entries. That's the term that we want to use for this particular topic of matrices. All right? So what will I add to 73?
82.
What will I add to 73? 82? You said corresponding elements, so you have to make sure.
50.
50. Why are we adding 50? Why not the 82 as what was mentioned earlier? Can anybody tell me? Why do we add 73 to the 50? The corresponding in the same place, same position. So this right here is going to be, let's say, X. How would I write this with the numbers? What numbers would I write right here to represent the 50? X12, X11, X21, X22. I don't know. Tell me. What do you think? What I'll write under the 50? X what?
X22.
All right, subscript. And what about the 73? Why is it X or Y? What should I have? X or Y? Okay, common letters, 2, 2. So this is how I know that I should be adding them. All right. So let's go. So we identify the corresponding elements. So let's continue. So we have the 40 added to the 50. So the corresponding element from in matrix X is added to the corresponding element, in matrix Y. So 40 and 50 gives you what? 40 added to 50 gives you? All right, 90. So what about 71 and 82? Are those the corresponding elements? And then what's the total? Okay, what's the total now? All right. What about 30 and 90? All right, that gives you 120. Okay. Now, what does the 123 mean? What information is the 123 telling us? Can anyone tell us? The total of what? Yes, continue. The total of what?
X and Y.
The total of what?
The total from 50 to 73
Yes, but what does that total represent?
represents the amount of runs.
The amount of runs in what? The first innings, the second innings, and by who?
Joshua.
You sure it's Joshua? All right. So it's the total runs made by who in both innings? Go ahead. All right, let's see.
The total number of runs made by Joshua in the first and second innings.
All right, the first and the second innings. Let's go back for emphasis, just so the persons can see it. So Joshua's runs in the first innings was 50. Against which school? Yes, somebody actually mentioned it, but against which school? Against school B, right? So that's a 50. And what about the 73 now? Is it the same school B or is it a different school? Okay, so it represents the total amount of runs Joshua would have made in the 2 innings against which school? School B. So it's not just about runs. Runs by who? In which innings? Is it 1, 2, or both of the innings? Right? And against which school? So that's how the information speaks to us. What about the 90? What does the 90 represent? The entry 90 for the total.
Or the number of points gained from the 2 innings made by Joshua from school A.
Is it Joshua? 90. Look at the 90. Where is it?
From Sean.
Okay. So this 90. Remember that the first row is Sean. You can always write it back. This one was Joshua. And what the column says, is it A or B for column 1? Is it school A or is it school B?
A.
Okay, and this is B. So you can literally put back these things, you know. It's your paper, your rough work, your book. So you want to make sure you answer the question correctly. So it's Sean's total for the 2 innings against school A, all right? So whatever you are given, whatever you got earlier, you want to use it back. It is not abstract. They gave you a scenario, so use the scenario. The next one, how can we calculate how much more was scored by each player in the second innings against each school using the matrices formed previously? So we have the 2 matrices, X and Y. So how do we find that value? What will we be doing? Will we add or subtract? All right,
Subtract.
So subtract. All right, so what are we going to subtract? How would that matrix subtraction look like? Would it be y minus a? Yeah, sorry, repeat that one. Okay. Is it going to be y minus x? Or is it going to be x minus y? Or is it
X minus Y.
X minus y? Why x minus y? You're trying to find out how much more was scored by each player. So again, which one will you write? X minus y or y minus x? Everybody is in the chat is saying y minus x. Why do we start with y and not x?
Because if you start with the x, you're gonna get a negative number.
All right, and you want to find out how much more, right? So we're trying to say, it might imply that more runs were scored in the second innings, right? So you want to find the difference between that, the 2 innings. So yes, we do y minus x. So what's the first thing that we do? Check our compatibility. Are they compatible? You would have mentioned that already. Matrix X and Y are compatible. It's a 2 by 2. All right. See if you can do that quickly in your books. Y minus x. What would that look like? What would the final value be? Or the matrix that we'll have when you subtract. Do that. I'll give 15 seconds for that one. And let's see what we all come up with. Oh, they are compatible because not like terms. It's about the size or the dimension. So what is the dimension? It is how many rows we have in this first matrix, which is X. So we have 2 rows by, we have 2 columns. So that's how we get 2 by 2. And we do the same thing over here. So it has 2 rows and 2 columns. All right? All right, good. So again, just emphasis on the persons who would have catch it a bit late. There is a YouTube recording. Well, there will be a YouTube recording once this is finished. So you can do it in your own local leisure time. I know that we might be off doing other things, but yeah. All right. And again, you have a Jamaican voice and not any other Caribbean accent. So you should be okay. So you don't have to worry about, oh, I can't understand. So yeah. All right, let's see. All right, let's see. All right, so I'm seeing some answers. So let's see. So we identify the corresponding elements. So we indeed have 10, 11 in the first row, 60, 23 in the second row. So most participants would have given me that result. All right. So again, just for emphasis, let me go back to the first. So it's 50 minus 40. And if you're using a calculator, make sure you actually input in the same entries or elements. It's 50 minus 40, not 40 minus 50. So ensure that you put it right in your calculator because it will give you something different. And don't blame the calculator. Okay, next one. So 50 minus 40 is 10. 82 minus 71. Most persons got 11, etc. And make sure the values are correct. 90 minus 30 gives you 60. Okay. 73 minus 50 gives you 23. Now let's see. Yes, we got a numerical value, but can you tell me what these values represent? Let's start off with 11. What does 11 represent, the element 11 or the entry 11, represent for our scenario that we had? What does 11 represent? Can anybody open your mics and tell me? Can anybody type in the chats as quickly as possible? Yes, go ahead. Oh, can't hear. I guess that wasn't for me. Sean got 11 more runs in the second innings against School B than in the first. Yes, that's cool. That's right. Nice. All right. And emphasis on actually answering the question as how you should, and not just saying, oh, that's how much Sean got in Sean got 11 more runs. That's all. No, that's not all. You have to make the statement be known that it's not just 11 more runs, but 11 more runs in the second innings against School B than in the first innings. Is everybody okay with that? So
Yes,
it's not
sir.
it's not just about doing the maths. You gotta understand the math, right? Because if you just keep on doing something abstractly every single day, you might say, I'm tired of this now. I want something new. And we always repeat and say, we want to see application questions. Go ahead, Mrs. Matilda Darvik. Your mic is open. You want to speak?
Yes, I just want to look at another matrix. Suppose we had a matrix, you can write this down. 30, 40, 50.
Give me a second. All right, go ahead.
So this is a matrix Z, and the matrix is 30, 40, 50.
All right, in which order? You have to tell me the order.
Yeah.
This order? Is this
No,
fine?
up the top row is 30, 40, 50.
Oh, so that's why I was asking. All right.
Yeah.
So again, you see, kids, how it's important to differentiate between the rows and columns.
Yeah, 30, 40,
So
50,
30,
row 1.
30, 40.
40. No, okay, all right.
This way?
All right, go across the row. 30, 40, 50 in row 1.
Oh, wait. Give me a second.
And I hope everybody's
I'm a
as
visual
confused
learner.
as you are.
I'm
30,
a visual
40, 50
learner.
is row 1.
All right, go again.
30, 40, 50, row 1.
All right. Yes, I'm a visual learner, everyone. Continue.
Okay, and then in the next row, we have 10, 20, 30.
10, 20, 30. And yes, thanks, Hobson. I needed that one.
So, can we see, I'm going to ask you now to attempt, and the students to look at this as well, to attempt to add matrix Y and Z, and tell me what you notice if you try to do Y plus Z.
It's subtract, right?
Add
Oh,
Z and Y, Z plus Y.
They said you can't.
You can't. Why can't you?
They are not compatible.
They're not compatible.
Right. So you see what's happening. Mr. Lim is attempting to add the matrix, but the 50 doesn't have anything to add to it. So when we say the matrices are not compatible, that's what we mean. We can't find the solution for a part of the answer matrix. There's nothing to add to the 50 because Y doesn't have that third column. So when we say the matrix, the two matrices are not compatible, this is a problem we run into, and that is why you don't bother even to start to try and add the matrices. As you can clearly see, the 50 from the Z doesn't have anything in the Y to add to it. So Mr. Lim, you can put a big X beside all of that because it cannot be done. Because it's not compatible, it can't be done, it doesn't make sense at all. All right, thank you.
All right, thanks much. Oh, sorry.
And likewise, you wouldn't be able to subtract.
Yes, likewise. So now we're on to multiplying matrices. So similarly, not necessarily similarly to addition or subtraction, but we have some conditions that must be met for us to multiply matrices. All right? So we'll be going through that in a bit.
Right
So
before you get to the multiplication of the matrices, sir,
yeah.
we have just about an hour to go, young people. I know it's been a lot, so I'm just going to ask you to just take a big deep breath. In, out, perhaps go and drink a little water. Don't go too far though, you know. Just stretch your arms, stretch your legs. You're stretching, you know, you remember when you usually go to primary school and they say hands up, hands down, sideways, forward, back. Yeah, man. Stretch it out, yawn it out. Yeah, man. I know the information is a bit. I want you to digest the adding and the subtracting and being able to identify the elements and corresponding elements. Digest it. Wusa. If you're over there feeling flustered, don't. It's okay. If you missed something, you can go to our YouTube channel and rewatch today's session. You shake it out. Let me see. Give me some thumbs up if you stretch already. Run, drink some water. Let me see the thumbs up for those who have stretched.
I'm fine, miss.
Oh, Dejan, you don't need for stretch. All right. Okay. Ready for the multiply now. All right, Jacqueline, no problem.
Okay, all right. So I went for water myself. I took the initiative. Yeah, I took the thing. I took the directive. Thank you. All right, so on to multiplication. And we'll mention what do we mean by standardized tests close to the end. So you want to stick around to that part. And also, you want to stick around for the end of the presentation. Okay. So let's continue. So we have another scenario. Oh, as it pertains to, well, I'll address it in a bit. So in a competition, you have 3 points that are awarded for a win, and 1 point if the match was drawn, and 0 points for a loss. These are the rules and regulations, sorry, as it pertains to this scenario. So the results of 7 matches played by 3 teams. All right, the 3 teams. Oh, and remember, by the way, that we still have the registration forms in the chat. They will be posted again. So if you never got the chance to register, to mark your attendance for this session, it will be placed in the chat in a short time. All right, so we have 7 matches. So are we seeing that Team J played 7 matches? How do we know that Team J played 7 matches? It was said at the top, but sometimes you can make an error. So how are we seeing that Team J would have played 7 matches? Anyone can tell me? Anyone can type in the chat? How do we know that they played 7 matches? Yeah, what do you add?
So it's said that Team J won 3 matches, drew 3 and lost 1. So 3 plus 3 plus 1 equals 7. That is 7 matches.
All right, you want to check it for the rest of them for us right now? Go ahead. Team K.
Team K?
Yeah.
Oh, yeah, Team K won 2 matches, drew 1 and lost 4. Once again, 2 plus 1 plus 4 equals 7. So that is 7 matches total.
All right. And then last one, Team L?
Team L won 3 matches, drew 2 matches and lost 2. 3 plus 2 plus 2 equals 7.
And spectacular. Thank you very much for
No problem.
taking the time out and actually helping us with that one. All right, so everybody's clear with that? Everyone is clear with that? And how we got the 7 matches and how we know that they actually indeed played 7 matches. All right? And yes, you might be saying, sir, we can calculate this quick enough and get how much points each team gets at the end of those 7 matches, right? Yeah, we can do that quick because we can do it mentally. But again, we're showing you how matrices, the application of matrices is all around us. We might not think so, but we can make a matrices from this. All right? A matrix from this, my bad. So let's go. So we want to write a column matrix to represent the points awarded for win, lose, and draw. So a column matrix does that jog your memory? Does that jog your memory? You know what a column matrix looks like, what it should have? What should it have? Do you know what it should have for sure? Do you know what specifically it should have for sure? Should it, okay, a vertical line of, okay. So it has only one column. So let's go. So 3, 1, 0. So which one of these values or entries represents win? Where can I find the win? All right. And where is that actually? Let's say it was P subscript using the common letters, the P right here. So what would this be? P what? What would this be? P what? P what? P. Okay. First row, first column. What about the 1? What will the 1 tell us? Using the subscript thing. P what? P, second row, 1 column. What about the 0? P what? Subscript using the jargons. 3, 1. All right. So we have now which entry represents the points you'll get once you lose a match. Oh, sorry. I did it already. That's fine. I did it again. All right. So thanks for giving me the responses. Nevertheless, the 2 responses that came in before. So 3 points for win, as was mentioned, etc. So what about write a matrix to represent the results of the matches played by the 3 teams? Now, and that's matrix R. Let's think about it. How many rows and columns would I have in this matrix R for the matches that they would have played? Think about it. Give me the size or the order of the dimension of this matrix R that I will have. And remember, it's results for all 3 teams, not one, but the 3 teams. So what would be my size or dimensions of this matrix? All right, let's see. All right, everybody's saying 3 by 3 so far. And remember, it's for the 3 teams. So all of the matches played by the 3 teams. Remember, they would have won some matches, lost some matches, and win some matches for 3 teams. All right? All right, cool. Write that matrix for me now, please. Write it down in your book or on a piece of paper. Or think about it mentally. And let's see if you got that value, if you got that matrix. I want you to write it down.
You can go back to the information, sir, so that I can write.
So write the matrix given by Team J, K, and L, and the won, drew, and loss aspect of it. So now you're giving me numerical entries. And we all should know that it would be a 3 by 3. All right, so time has elapsed. So let's see. Did we all have this? Okay. And it's okay if you can't write it properly, because technically that would be a row. All right, cool, nice. All right, the first row. What does the first row tell us? What does the first row tell us? Good. What does the first row tell us?
Wins, losses, and something. There's
the win, loss. What does the first row really tell us?
Win, loss, and draws of Team J.
Team J. All right. So it really tells you the Team J's statistics, if you want to call it that. Once you have the YouTube link, it will be there after the session. So it's live right now, just answering a question. Thanks, by the way, the individual that would have answered. So the session will be on YouTube. So the first row is Team J, and the second is Team K, and the third is Team L. All right. And what does this? There are a lot of 3, so let me go with the 4. What does the 4 tell us about information for this particular context? What does the 4 tell us?
The number of losses for Team K.
Okay, the number of losses for Team K. All right, cool, nice. Thanks again for opening your mic and speaking. Now, we need to find out how we know we can get the answer very quickly, as I would have mentioned earlier. But we have two matrices. We have P and we have R. So which one do I write first? Right? Can I multiply PR or can I multiply RP? Let's see.
Both will give you the same answer.
Both will give you the same answer. Let's test that theory, yeah? Let's test the theory. All right, so we have P and we have the size of matrix P, right? Which is a 3 by 1. So 3 by 1 means it has 3 rows and how many columns? 1. I heard the 1. I kind of heard the 1. All right, and R, matrix R, it has a 3 by 3. That's the size or dimension or the order of the matrix. All right? And let's look at the next other one. So PR is at the top, multiplying matrix P by R. And at the bottom of the screen, you have R multiplied by P. Now, the first thing that you want to decide, or the first thing that you want to think about, is are the two matrices compatible? When I multiply P by R, is it compatible? When I multiply R by P, is it compatible?
Sir, it's different for this one.
Yes.
It's different for this one?
Yes, because it's not adding or subtracting.
Okay. All right. You want to change your order? Well, you can't change your order. You can't change the question. This is their question. This is our question that we're working. We can't change it. Let's see. Some person say it doesn't matter. Some person says it's compatible. But you need to tell me what is compatible. Is PR compatible or is RP compatible?
PR.
Okay, let's see. Let's get into it.
PR.
So, compatibility for multiplication. If and only if the number of columns of the left matrix is the same as the number of rows of the right matrix. And you might say, sorry, that too much to remember right now. Too much words. I can't be bothered right now. But we go into the chat and we say, no, something simpler for you to remember. In other words, the inner dimensions. Now, what are the inner dimensions? We have in, we have out. In, out. I don't know if you usually play that game, but yeah, I think I remember playing it vaguely, but something like that nature, something of that nature. So let's see. And let's see if anyone would change whatever they would have said originally. So that's what we mean by the inner dimensions. So the inner dimensions, the matrix on the left, which is matrix P, you look at the columns, which is 1. So let me just highlight this one. So that's 1. Then the matrix on the right, you look at the rows in that one. So that's what we mean by inner dimensions. So we have 1, 3. Are they equal to each other or they are not equal? Which is it? Equal or not equal? Is 1 equal to 3 or 1 is not equal to 3? Not equal. And we write, okay, not equal. So the inner dimensions are not the same number. So is that compatible or is it compatible? So is that matrix product, sorry, is that matrix, the matrices when you multiply P and R, are they compatible? No,
Yes.
no, they are not. And this is what we use, all right, to determine if they are compatible.
Not compatible.
All right? So not compatible. All right. Oh. So again, let me just go back. So we look at the number of columns in the left matrix, which is matrix P. And then we look at the matrix R on the right of the multiplication because it's PR. So this is left, L, and this is right. All right. So the 1 and the 3, they are not the same number. So you cannot multiply them. You cannot multiply matrix P and R together, looking like this. So they're not compatible. All right. So for this one, the matrix is RP. Is it compatible? How do you know What are the inner dimensions? What does the inner dimension tell you? Yes, it's compatible, but how do you know? You look at the inner dimensions. So the number of columns in the first matrix, which is now R, is equal to the number of rows in the second matrix. So that's another way to put it. The number of columns in the first matrix that you have, which is R, is equal to the number of columns that you have in matrix P, or the second matrix, which is over here. So 3 is equal to 3. So yes, they are compatible. All right, that's fine. Again, remember the session will be on YouTube, so you can always look through and when we have the other sessions to come. All right? So is everybody okay with the compatibility? Okay, all right. So RP,
Yes,
and someone would have said that they are commutative, but this is technically, when we get to that stage, we'll be at it very quickly, and to show you that what we call commutative. All right. So it's only commutative for regular multiplication, right? But not in this matrix topic or this particular question. All right. So there could be cases when it is commutative, but in this question that we're working, it is not. All right, because it's not compatible at the beginning. All right. So that is something also to note. So how do we determine the size of this resultant matrix? You might be wondering, what is the resultant matrix? We'll find out a bit too, and we'll tell you what another name or term we can use for resultant matrix. So this is the number of rows in the first matrix and by the number of columns in the second matrix. In other words, again, the shortening version is the outer dimensions. All right? So let's see how that works. So remember that we found out that they are compatible, which are using these two values. So what numbers represent the outer dimensions? Which numbers do you think will represent outer dimensions? Which numbers do you think will represent outer? So this is the inner. So what would be represented by the outer? The 3 and the 1. So what would be my resultant matrix? What would be the order of my resultant matrix? What would be my size? It would be what? 3 by 1. So my what? What's another name I could write for resultant matrix then? What's another name I could say? When I multiply R with P, okay, my product, or you can say, some persons might say your answer matrix. All right? So that is also a different word that you could use. But we generally use the term product and resultant, but more product than resultant. So this is a 3 by 1. All right? Again, you would have used the outer dimensions. Now let's see. Let us try a few of these other examples. Tell which of the following matrices multiplications are compatible, and tell the dimensions of the resultant matrices after multiplication. So you're going to state whether they are compatible, and then you're going to give the resultant if they are compatible. So if something is not compatible, when you multiply two matrices, if they are not compatible, do you think that they will have a resultant matrices? No. So that's what you write, no. So once you find out that they are compatible, you will have a resultant matrix or a product matrix or your answer matrix. All right. So I'm going to give you about 30 seconds or so to try questions. You can take the screenshot and try the others when you get the time. So you're going to try this one, number 1, number 2, sorry, number 4, and number 5. So you're going to try 1, 4, and 5, and I'll give you 30 seconds. So some persons can do question 1, others can do question 4, and the next set does question 5. All right? So if your school is going from start with the letter A to about, what should I say, H, you do question 1. So A to H, you do question 1. Then I, if your school name starts with an I, all the way to, I don't know, P.
A to K, sir. A to K.
A to K. Oh, K, you want me to K? All right.
Yes, A to K.
Okay. I thought that I got it wrong. A to, oh, sorry. My bad. A to K. You said A to K, right?
Yes, sir.
And number 2.
And then
Number 4, sorry.
L,
L2.
Z.
Z? Just 2 questions? Okay, just 2 questions. All right.
Oh, there are 4 questions.
Oh, yeah, that is fine,
And then,
man.
and then everybody do 5.
And everybody do 5. See there? So each person do 2 questions.
That is just to tell if they are compatible, and if they are compatible, the size of the answer, the resultant matrix. That's all.
All right, question 1. Any takers for question 1? Are they compatible? Yes or no? Who said yes? Question 1, question 1, question 1. Are they compatible? Okay, let's find out if they are compatible. So, no, they are not, because we have a 3x2 for the first matrix and a 3x2 for the other matrix, yes? But the inner dimensions are not the same number, all right? So they're not compatible. Not because you have a 3x2 and a 3x2 when you're multiplying, but if you should add or subtract, you can actually add or subtract. All right, Bartley? You can add or subtract, but that's not the operation that we are doing right here. All right? What about question 4? Any takers for question 4?
They are compatible.
They are compatible. So let's see. So question 4, this is 3x1. And what is the other matrix? What is this matrix? What is the size?
1x3.
1x3. Are they compatible?
Yes.
Yes, we use the inner dimensions. And yes, I'm getting a smiley face. So this one and this one, they are compatible. So what would be the resultant matrix?
6 on 6. Oh.
Which one? Go ahead.
And that is just the size of the answer, not the answer, just the size of the answer.
Yes.
The dimensions of the answer.
Oh, he actually calculated it. My bad. I should have said that differently then. Sorry. What is the resultant matrix, or what is the
dimensions?
The dimensions or the size of the resultant matrix or the product. Yeah, most persons would have said 3x3. All right. All right. And the others you can do in your own leisure, right? So you can take the screenshot, 5 seconds, take the screenshot, then we move on. All right. 5, 4, 3, 2.
You close the mic, sir.
Oh, yeah, I closed my mic. Yeah. All right, thanks. Now, matrix multiplication. So, something that we want to take into consideration. After we find out that they're compatible, then we want to actually multiply. And how do we multiply? Of course, we're going to use multiplication or multiply. But the emphasis should be on the
Row by column.
row by column. Yes, row by column. So we have different ways of remembering what to do, yes. So this is just one way of doing it. You might have researched and got different methods if you should do that. Your teachers might give you different strategies, etc. So whichever one works best for you. But for the individuals who would have not seen this before, this is just one way or one strategy. All right. So it's not written in what they call it, stone. Yeah. So we multiply row by column and then we add. So we have matrix X and Y. So we have matrix X on the left and matrix Y also on the left, but it is to the right of it in this scenario. So X multiplied by Y. All right. So we want to multiply these two matrices. So the first thing that we check is what? Are they compatible? Are these two matrices compatible? Yes, no. Are these two matrices compatible? How do you know? What do you use to check? What do you use to check? What do you use to check? Inner dimensions, okay. Your compatibility. What are the inner dimensions? What are the numbers? What is the size of matrix X? Okay, I see 3 by 2 for X and Y, 2 by 3. All right, so they are compatible. All right, and what would be the resultant matrix size? What would be the resultant matrix size? My bad, I went too fast. Okay. All right, 3 by 3. All right, so let's go. So when we multiply X by Y, we get Z. That's our resultant matrix name or the product's name. So let's go. We would have said this already. So the 2 and the 2 in a different color shows the compatibility. And the 3 by 3 shows the size of the resultant matrix. All right, so again, emphasis on the row. So which row do we start at? Do we start at X or in Y? No, we start at X. Whichever matrix is first, as in most, the one on the more what should I say? On the left side of the two matrices that you want to multiply. So you start with X. So you start with row 1 in X. And as I said before, row, then column. So what column should I look at now? What column do you think the oval will be in? Or what column should I highlight next? Which column and where? The first column where?
Column 1.
Column 1 where? In X or Y?
In Y.
In Y.
Y.
All right, cool. So let's multiply. 1 is going to be multiplied by what? 1 in the first row is going to be multiplied by what? A. All right. So do I write, where is it? Do I write 1A and then I continue and say 2 multiplied by what? 2 multiplied by what? What value should I multiply 2 by?
2 multiplied by D.
Okay. Should I leave it like this? Is this okay?
No, sir. You're going to put
What should I do?
1 multiplied by A plus 2D.
All right. So what was missing? The addition sign. So this is why I would have made emphasis and say, not just row by column, multiply, yeah. But you got to remember the addition sign between the multiplications. All right? So that's what we would have had. Let's see. Let's go. So you are indeed correct. What about the next one? So what should I do next? What do you think I'll do next? Row by column. What should I do next? I'm finished with that first row.
4 by B and E.
Which one?
Multiply 3 and 4 by B and E.
Oh, well, sorry. I'm going to do the first column. As in the resultant matrix over here, I'm doing the first column. So I'm going down and not necessarily across. All right? So going down, I finished the first row. So what row should I move on to next? And where? Oh, go ahead. All right, row 2. So I'm going to move on to row 2. So do I now move on to column 2 in matrix
Yes,
Y,
sir.
or do I stay in column 1?
Column 2, sir.
You sure? Somebody says stay, somebody says move. What should I do? Stay or move? Stay. You want me to stay?
Stay.
Okay, I'll
Stay,
stay. I'll stay past 12 o'clock. I'm joking, I think. All right, so 3 multiplied by what? So I stay. We need to stay because we need to finish all of the rows in the first matrix. Then we continue like that, okay? So once we finish with all of the rows in the first matrix, then we continue until we're finished. So 3 multiplied by what?
A.
So 3 multiplied by A, and then what? What do I write after that?
You're gonna write 3A.
Yes, 3A, and then what comes after? What comes
Then
immediately after?
then
Plus.
4. Yeah, plus.
That's addition. Yes, that's key, right? So the addition comes after. Then what do I multiply 4 by?
The D, and then you get 4D.
All right, so I get it, right? I got 3A added to 4D. So what do I move on to now? What's the next thing I move on to?
Third.
6.
Which row do I move on to? Am I finished with all the
Row
rows
3.
in X? Oh, I
No,
got the
sir.
third one. All right. Now, do I stay in that same first column in Y, or
Yes,
do I
sir.
continue?
Yes,
Yes,
sir.
All
sir.
right, stay. All
Yes,
right,
sir.
so I got stay. All right, and when we multiply, we get that value. All right, so are we finished now with all of the rows in column X?
Yes.
All
Yes,
right,
sir.
so we need to continue, right? Right, because we need to get a 3 by 3. Right now, this is a what matrix? If I should leave this alone, what would this matrix size be? A 3 by 1. And what should I get as my final answer? As in the size of my final answer. It should be a 3 by 3. So I need to go again. So let's go. So notice now, I'm at the second column in the second matrix. So I start off again, just like what we did earlier. So first row by the second column now. First row in matrix X multiplied by the second column in matrix Y. So we go 1 multiplied by what? B, right?
B.
So help me. Go faster so we can go faster. 1 multiplied by B, then what comes
1B.
2
Then
multiplied by
the
E.
addition sign.
Add the 2 times what? 2
E.
times E.
E.
All right, cool. Nice. Next one. We'll continue. 3 and 4, second row. What should we
3
do next?
multiplied by
3 multiplied
3B
by.
plus 4E.
3B
All
plus
right.
4E.
We can say a little bit faster, I know. A little bit, not too much. And then what do we do? Multiply 5 by.
5B plus 6E.
5B plus
5B
6E.
plus 6E.
All right. So once we hear the noise, we know say something not going on. All right. All right. So are we finished right now? Do I stop right there
No.
and say I'm tired, my boss? We can't finish right there.
No, sir.
No, sir.
No.
All right. How do you know that you need to continue though?
You invite a 3 by 3 matrix.
Okay. And also you literally have one more column on Y. All right. So let's go. Again, that's why it's so important, row by column. Once you understand the row by column objective, it's not column and row, it's row by column and such. All right. So we go on. 1 times what? 1 times?
C.
C.
Okay. Plus.
2.
2.
All right. 2F. 2 times F is 2F. Then 3 times what?
C.
3C.
Added to?
4F.
4F.
All right. Then last one, 5 times what?
C.
5C.
Added to?
6F.
6F.
All right. Cool. So now we stop. We know we're on the right track. We get all of the values, right? And remember that these are variables. This is algebra. This is how algebra is so important. This is why you learn it in your previous years at school, in 7th to 9th grade, the lower school years. So you don't want to miss those. You don't want to have missed those sessions, right? So we continue. So that is how you can take a picture if you want, a screenshot or so. So this is how we would multiply these matrices, X and Y, to give us Z. And we have the sizes, the size of the dimensions of these matrices, and how we know that they're compatible, and the value that we should get, as in the size of the matrix that we should get when we're finished multiplying. All right, so going back to the same scenario that we did earlier, I mentioned earlier about the team. And remember, I said we could have calculated a bit quicker from the get-go, but we want to show you how matrix is applied to these type of questions or these type of scenario. So RP, not PR, RP, we would have said that is compatible, right? Because of the inner dimensions and such. So team results is the first matrix, which is matrix R. So this is R, this is P. Now, we would have decided that they're compatible, 3 by 3. and that we would have also understood what the size of the product of the matrices would be, which is a 3x1, which would give us our total values, total points earned by each team. Now let's do the multiplication. Again, row by column. So what should I multiply? Tell me what I should multiply. Row, for the first row, what should I multiply in the first row? And all of that.
3 by
So let's
3.
3 by 3 multiplied by 3, added to what? 3 added to what? 3 multiplied by 3, yes? And what else?
Plus 3 by 1.
Okay, let me write it down. 3 by 3. Well, let me write it down right here. 3 by 3. 3 times 3, sorry. Added to what?
3 times 1.
Okay. And one person I hear talk now. What is happening over
Plus
there?
1 by 0.
1 by 0. So
No,
row by the column. Row by the column. All you gotta remember is RC. RC is your life right now until you finish. So we continue and we do the 2 and the 2 and 4, right? So work it out. Work out all of the values and let's see what you get before I do the big reveal. I'll give you about 30 seconds. So you have 30 seconds on your watch or on your phone right now, on your stopwatch. Let me do the same and let's get through this together. So you have 25 more seconds. And let's just see if you got this value. And everyone is okay, right? By the way, just asking. All right, good, Shanika, you would have said in a column format. All right, cool. Clark, check what your values. Oh, I wasn't referring to the first row only. I was referring to the final product. So Clark, yeah, you're there, but you need to, do the others. All right, time is done. Time has elapsed. All right, cool. So let's see if we got the values. So we'd have multiplied all of those. And then that gave us, in the first row, 9 plus 3 plus 0, as Clark would have mentioned. But the other rows, 6 plus 1 plus 0. And the last row, 9 plus 2 plus 0. So again, this is what we are referring to. Look at what you got, Janika and Horton. You notice that there is no addition sign in the values that you would have given, the entries that you would have given. And then notice again that that is not a 3 by 1, because remember that our sides are 3 by 1. So I don't know if you forgot to put the addition sign, but yeah, the addition sign should have been a calculation. All right, cool. All right, at least you can self-correct or correct me if anything. All right, let's see. So let's see when we add. 9 plus 3 plus 0 is 12. 6 plus 1 is 7. Added to 0, that's 7. Then 9 plus 2 plus 0 is 11. And we got the answer. Now, as you can see, our final value, our final matrices is going to be, yeah, all right. Okay, all right, cool, nice. So our final size of the matrices that we have when we multiplied is a 3 by 1. So this is our crucial understanding the size of the dimensions of the matrix. All right. I will give you one more to do, yes. All right. So what does that 12 mean, by the way? The 12, what does the 12 stand for? What does the 7 mean? What does 11?
The total
How is that
score
significant?
for Team J.
Okay. Continue.
Oh, and the 7 is the total scores for Team K. The 11 is the total scores for Team L.
All right. Funny thing. How many games did they play again?
7.
7. So which
7.
team got the same amount of points same amount of points,
Team
the
K.
same amount of matches that they would have
Team
played?
K.
7. And who got the most points?
Team J.
So Team J. And who is the champion?
Team
Currently.
J.
Team
Team
J.
J. So if
Team
your
J.
name is J, If your name starts with J, you're a champion. I mean, my name starts with J, so why not? All right, so let's continue. So that's what it really means, right? Yes, I'm big up all of the persons that name with J. All right, so again, Team J, they had 3 wins, 3 draws, and 1 loss, and they would have been awarded 12 points. And we get the gist of what that matrix is actually saying to us. So don't think about it as being so abstract and being, oh, this doesn't make a sense, I don't need to know it, right? So when you're doing IT, when you're doing Excel sheets, all of those things, they come out, they use the matrix, they use matrices in order to analyze and get the correct answer. All right? So again, this is how we use it on a daily basis. Not just educators, not just teachers. Everyone technically uses it, but they don't realize that they're using matrices. So some practice questions. All right, let's see if we can do this as quickly as possible. So these are multiple choice items. So given that A, 1, 3, -3 in row 1 and row 2 is 3, 0, 5, they want to determine the value of 3 multiplied by the matrix A. That's what 3A means. So let's see if we can get to this value. Come on, let's see. What would it be? A, B, C, D? How do you know?
A.
What am I doing? How do you know it's A? Come on, how do you know that it's A?
Sir, the answer is A.
How do we know that it's A?
Sir, we're gonna
We multiply 3A by 1, 3A by 3, 3A by -3.
Okay, so each element is multiplied by what?
Sir, each element in the bracket is gonna multiply by
And
the 3.
I hope that you will remember this when you're doing algebra or when you did algebra for expansion, because oftentimes we forget to multiply everything in the brackets by what is outside, in other words, our scalar, right? So again, you got to remember that. All right, so 3 times -3 is -9, not 9. So this is how they catch, or they might catch some persons. All right, so we then multiply each element by 3. This is just a short working out. So if you want, you could take this image. All right, so you could take this picture. I'll give you about 10 seconds. All right, that should be enough. All right, what about this one? Oh, I think I forgot to put the question. So the question is, what is the order of this matrix?
So it's C.
C.
C by 4.
It's C.
Sir,
Who's saying A? Who's saying C? All right, how many rows do we have? First of all, how many rows do we have?
3.
3.
Which one comes first? You look for the 3.
Rows.
Yeah, the rows come first. You look for the 3. This no have 3 first. So I'm gonna write this. So I'm gonna go down here. Do the same thing. You're eliminating the impossible options. You're left with 2 options. Then you say column come next. So how many columns does it have? 2 or 4? 4.
Yes,
So
sir.
it's out of the way. So what are you left back with? You're left with C. So you want to use this elimination process, not just a guessing game. All right? I'm not looking for technically the odd one out, because that can actually not be the answer. So the solution, we would have identified the amount of rows, which is 3. And we would identify the amount of columns, which is 4. So 3 times 4, 3 by 4 is what the result would be. All right? So you can take that image if you want, and such. So this would be the correct one. I don't know what this is. So this would have been the correct one, 3 by 4. All right, so you can take that image and we move. All right, matrix multiplication can only occur if, is it A, matrices of the same size? Is it B, matrices are equal to each other? C, the number of columns in the first matrix is equal to the number of rows in the second matrix. And finally, D, the number of rows in the first matrix is equal to the number of columns in the second. Which one do you think?
C.
C? Why not A? Come on. Why not A? Why not A? Why not A? A could be a possible option. I mean, I don't know. You tell me. Why not A? Can anybody tell me why it's not A and why is it so C?
Because
C, the blind man?
the inner times the outer and it's not the same.
Okay. All right. All right. So just using an example that we used earlier, the 3 by 3 and the 3 by 1, when you are multiplied, the number, the number of rows, number of columns, sorry, in the first matrix, which is matrix R, is equal to the number of rows in the second matrix, which is 3. So this would indeed be C. What about this one? A square matrix A multiplied by the identity matrix I is equal to what? What do you think would be this answer? Okay, one person is saying D. You don't get it? All right. All right, first of all, what do you remember as a square matrix? What is a square matrix?
Same amount of row and column.
Okay, same technically I have an issue with the amount, but number. All right. So let's say, and what is an identity matrix? What do you remember as an identity
A
matrix?
special square matrix.
Special square matrix. So how is it special? It uses zeros and ones, but
Each element on the main diagonal is
what?
1, sir.
And what about the other elements? And the other elements?
Zero.
Yeah, 0. All right. I see that you remember that verbatim from the slide. All right. So the solution. So I have a matrix. I have a square matrix. How do I know that A is a square matrix? Is it a square matrix? How do you know? You would have said the number of rows and columns would be the same. So this is a 2 by 2. And I want to also check matrix I. Is it a compatible square matrix? Compatible identity matrix. So we have to check all of those things. Because an identity matrix doesn't have to stop by a 2 by 2. It can be a 3 by 3 identity matrix. It can be a 4 by 4, a 5 by 5, etc. So you have to make sure it is incompatible. So this is how we check again, 2 by 2 and 2 by 2. Because we couldn't have multiplied an identity that is a 3 by 3 because it would not be compatible. So this is why you drag for something that has compatibility. All right. So we go like that. We check for compatibility, which is 2. They both have 2s. All right. And then now we multiply. And we just did multiplication. So row by column. So what will I multiply 2 by? What will I multiply 2 by? 1. And what would I add that value to?
11.
11 what?
Times
Just 11
0.
so 11 times 0. So that's what you write. 11 times 0. All right. And we continue. The second row, 3, 6, multiplied by the first column. We stay until we finish. All right. So we multiply, got those values, and we'd have done the same thing for that one. So what does this give us? 2 times 1 is 2. 11 times 0 is 0. Oh, okay, yeah. And going all of that, we would have gotten those entries when we do the addition. So our final value is that when we multiply the matrix A, which is a square matrix, by the identity matrix, also another 2 by 2. But again, we could have done a 3 by 3A, but a 2 by 2A is quicker to do. So that's why we did it like this. So what do you notice when you multiply A by I? The square matrix A by I, what do you get back? You get the same thing that we started with, which was A. So what will happen? What will be our actual answer? Our answer would be
C.
To get back matrix A, I should highlight, not just A. All right? So what do we say? We say that the matrix multiplication of a square matrix A by the identity matrix gives matrix A. All right? So even if it was a 3x3 matrix A, and a 3x3 identity matrix, it will still give you A. All right? Who had their hand up? Oh, go ahead.
All right, so I typed it in the chat, but just in case person didn't see it, what is useful to remember is that your identity matrix is just like the number 1 when you're multiplying. When you multiply anything by 1, you get back the same thing. So your identity matrix operates in multiplication just like the number +1 does in multiplication. So in the same way, if you think about if you multiply 1/3 by 3, what do you get? 1. So in the same way, when we get to it later on. So just jumping ahead a bit, when you multiply something by its inverse, you get 1. So the identity matrix operates just like the number 1 when you're multiplying. So I hope that helps you as you go forward with your multiplication of matrices.
So yes, that does help us. All right. Well, you know, like some persons like to see it to believe it, you know? So that's an additive as well. Thanks much, Miss Harris. So that's our answer. You can take that screenshot. And you might be saying, oh, it's time to go and all of that. But guess what? We have 5 questions. So I would like what you can do, or what you will do, is to attempt these 5 questions. And then once you have the question, you write the actual question and you have the screenshot, and you can direct it to your teachers at your school and ask them if it's correct or not. All right? So I will leave you with this activity for everyone to attempt. So take the screenshot, 5 questions, all 5 are what we actually did today. So this is just to test how you would have highlighted that. And Mrs. McNeil Darby will make reference to the standardized test. So you can go ahead, Miss McNeil Darby. Sorry, my bad.
Sir, not
Yeah, go ahead.
to confuse, but IV, is there a
IV,
W?
Yeah, that's a W, man, yeah. If W is equal to 2U, then determine the value of W. Yes, you might say, oh, they never gave us W, but what did they give you? So think about that, all right?
I would also want to note that it is not IV, but it is 4 in Roman numerals. So we're actually counting in Roman numerals, sir, and that IV represents the number 4. These are little things that you should remember, you know. All right, so what a day. I really hope that I don't have to hope, because I've heard and I've seen in the chat that this session would have been very helpful. I see you responding and answering questions and asking questions. And we thank you very much for coming and staying. A lot of you stayed, and we are grateful, and we hope that we would have helped you to better understand matrices for those who would have done it before, and for those who are seeing it for the first time. I hope that you would have learned something. I have placed the evaluation link in the chat. That is very important to us. We want to hear from you to ensure that whenever we have these sessions, we are meeting your needs. So I'm asking you kindly to click on the link in the chat so that the session can be evaluated. You can also scan the QR code on your screen. So either the link in the chat or scan the QR code on screen. So at this time, I'm going to pause and give the floor to Mrs. McNeil Darby for her to share.
Good afternoon, everyone. Mr. Leamy hinted at a standardized test. And by standardized test, we're saying that all of the students will do the same test. So it is expected that you will get a test which will include matrices and other topics. Especially what you have been doing in the last 6 weeks if your teacher was following what we call the scope and sequence for grade 11. So the test will cover some things that you did in grade 10, as well as what you have done since you are in grade 11. And one of the topics is actually matrices, and it goes way beyond what we did today because we actually stopped at multiplication